All right, guys, 4.1. Here we go. Put your name on it now. And put your period, 1, 2, 3, 4, whatever it is. Okay. So, some but not all of the representations in each set model in the situation described. Wait, some but not all of the representations in each set. Oh, model the situation described. Got it. Answer the questions for each problem. So here's the situation. The store is having a sale. Every item in the store costs $2. So let's say that you're buying balls. Each ball is $2. And you get to subtract $1 from your total bill. Apparently you have a coupon. So there's a situation. Here's a picture of it. The rule is I take the number of items I have, multiply it by $2, and subtract 1. Okay? The number of items I have is 1. That means it's $2 minus 1 is $1. So that's, yep. $2, so 2 items, that's $4. Subtract 1, that's 3, okay? 6 times $2 a piece is 12 minus 11, so that's right. And then if we had to graph these, it'd be 1, 1. Wait a minute. It'd be 2, 3. That's 2, 4. Let's see what's going on. Does the algebraic rule match the situation? Yes. Because X is the number of items and Y is the cost in dollars. So the cost in dollars, I'm just taking this algebraic equation and putting it back in English, is my equal sign, $2 times the number of items. So the cost in dollars is 2 times the number of items, but minus $1 because of our coupon. So yes. Does the table match the situation? Well, we just talked about it. If we have one item, that's $2. Take away $1, you get $1 left. 2 items, they're each $2, that's $4. Take away my coupon, that's $3, so that works. 6 item is 12. I don't have enough fingers for that. Take away take away $1, you get 11. So yes. Excuse me. Explanation is the number of items is correct for the number of dollars. So the cost is correct. Does the graph match the situation? Well, there should be a dot at 1 when X is 1 and Y is 1. So when X is 1 and Y is 1, they meet up right there. 2 and 3. X is 2, Y is 3, they meet up right there. 6 and 11. Over 6, Y is 11, I'd be way up here. So no, it doesn't. Here's where the dot should be. So why is it not right? The dots are not in the right place. Okay, well, that seemed pretty easy. Let's see about the next one. Bananas sell for 60 cents per pound. Expensive bananas. It says that the algebraic rule is y equals 60 cents x. Well, let's pick out what y is. According to this, the y is the cost in dollars. Cost in dollars. And x is the number of pounds. And we got number of pounds here, cost in dollars, number of pounds, cost in dollars. Okay, so let's talk about the algebraic rule. Does it work? Does the cost in dollars of your bananas always equal 60 cents times the number of pounds? Yes, it does. And let's just write it out in English to explain. So the cost in dollars is my equal sign, always equal to 60 cents times the number of pounds that I bought. Pounds of bananas. So yes, that works. Does the table match the situation? Let's see. Well, for 2 pounds, they're 60 cents each, so I should do 0.60 times 2 in my calculator. So try that in your calculator now. Do you get 160? I didn't either. I got $1.20. Let's try for 5. is 5 times 0.60. Try it in your calculator. Did you get $4? Neither did I got $3. So no, the cost is incorrect. Finally, it says, does the graph match? Well, let's see. These points are wrong. We've got to know these points to put them on here. So let's redo this. If my number of pounds is, we've got 1, 2, 3, 4, and 5. So 2, 3, and we'll do 4. So number of pounds, and here's the cost. So let's put 1 in our machine. If I put 1 in here, 0.60 times 1 is 0.60. Put 2 into my machine. 2 times 0.60 gives you $1.20. Put 3 into my machine. 3 times 0.60 is $1.80. And put a 4 in. 4 times 0.60 is 2.40. So let's see if they match up. I'm going to go ahead and mark my 50 cents each time, just so it's a little easier for me to see. So $1.50, $2, $2.50, $3, $3.50. Just so it's a little easier for me to see where it is. So when number of pounds is 1, the cost should be about 60 cents. That works out. When the number of pounds is 2, it should be $1.20 more. So that checks out. When the number of pounds is 3, I should be over at about $1.80, just shy of 2. So that works out. So yes, the dots are in the right place. Sorry, a little shaky today. Okay, cruising. Next, whenever water comes into contact with heated underground rocks, geothermal energy is generated. Well, I'm confused. I don't know about you, but the good thing is I do not have to be a scientist to understand that. The underground temperature of the rocks depends on the rock's depth below the surface. So the temperature of the rock depends on how far deep it is underneath the surface of the earth. The temperature is T in degrees Celsius, is estimated by following the algebraic rule, where D is the depth. So let's break this down. T is my temperature. Temperature, you know I can't spell. When in doubt, shorten it, temp. D was the depth in kilometers, so kilometers deep. So they're saying in this that the temperature of the rock is always equal to the number of kilometers deep it is times 35 and then add 20 more. It's pretty deep. We need to complete this, okay? So we're going to take 35 times our input plus 20 each time, right? 35 times our input plus 20. So I'm going to go ahead and set that up for each of them. Now we can plug them in. If I plug in first mistake, plug in a 2. My 2 goes into my machine. In your calculator, PEMDAS says I have to do my multiplication first. So 35 times 2 is 70, plus 20 is 90. Plug in a 3. Do 3 times 35, and then add 20. What do you get? Then do the rest. Pause it here. Realize right here that it's 5, 8, and 10. See you in part 2.